Okay, so why do we do a roughing first? There is a lot of material to get through in a 3-inch block before you get to your model surface. The vast majority of CNC bits and passes are not able to go that deep. The strictly deepest that a CNC bit, at least on our equipment, can probably ever go is about 1 inch, and that's through foam. So just about every 3D operation needs a roughing to clear material out first, unless you're only going very shallow to start, and then you might be able to start with a finish. So after you've done the roughing, we'll set up a parallel finishing. Just like the 3D roughing, the parameters of this are easier to set up than a 2D one. Select curve regions, same region as the roughing. Tool, same tool, don't need to remake one. You'll have to set the feeds and speeds again because it's a different type of operation. And I'm going to use those same numbers. As a starting point, clearance plane should be fine. Cut parameters. There's only ever 2 things you'll need to touch in this window. One is going to determine the finish quality of your object and is probably the biggest time sink and expenditure that in this operation, and that's the step over control. So there's a little diagram here that shows you what step over looks like. Sort of more realistically, when you're looking at your part, step over is going to determine the shape of tooling marks left on your material afterwards. Naturally, the tighter your step over, the more smooth a finish you're going to get, but you're also going to very proportionately spend that in time getting it. So 25% is a pretty quick step over. You'll see the lines definitely. It's not really until you get under 10% and even down to 5 that it starts getting very smooth. Let's just say 15 for now and sort of strike a balance between those 2 things. You do not need, in most cases, to mess with the rest of the parameters here. So all we did was we picked the control geometry, made sure it was the tool we wanted, set the feeds and speeds, and set the step over, and then generate. That looks more like our object. Notice that since it's a unidirectional path, a parallel path in this X direction of Rhino, that it's going to have a better time cutting geometry that's facing a certain direction than others. On these faces that are perpendicular to the direction of the pass, you're going to get a lot of tight tool paths there to shape it correctly. And on the ones that are parallel, you're going to have a harder time getting the tool because it's stepping over with a set number. And it's kind of like when you cut Z contours of a topography on very shallow terrain, you're going to get lines that are farther and farther apart. This is clearly different for every geometry you're going to encounter. Tighter parallel paths, the effect will be less pronounced. And you can always, in a parallel finish, change the angle of the cuts as well. So I just changed them 90 degrees. If I were to run both parallel passes on this object in 90-degree directions to each other, I would get a nicer finished object, but it would take twice the time, which in this is only going to be 15 minutes, but easily gets up to 6 hours if you're doing something the size of a site model. Okay, so that is a parallel finish. I make sure to drag it below the horizontal roughing in the order of things, just in case I want to chain them together. So right now, you should have a horizontal roughing that looks like that, and a parallel finish that looks like that. Notice the run out that I was talking about earlier. These tool paths get down to the bottom, and then since we drew the table plane in there, it has the opportunity to scoot out a little bit and cut a little extra around the object to make sure that it's completely cut out. If this table plane were not there, you're going to get something that looks like this, where it is cutting the entire thing, but since there's no geometry there, and it just sees down in Rhino to infinity, RhinoCam gets afraid and retracts the tool to the clearance plane every time, which is going to add a lot of time to your project and not get any better of a finish. So I recommend leaving it there. Notice that every time I change the geometry in Rhino, these little explosions happen on the folders for our operations, which means they've been broken because your geometry has changed. If you want to update them, simply right-click and click Regenerate.